put the magnet in if you would. All right, so law of sines. We've learned the basic trigonometry ideas using right triangles. Well, trigonometry does not just apply to right triangles. You can use trigonometry with non-right triangles. And so we are going to focus on law of sines today and law of cosines next time. And so we're going to use the idea to solve non-right triangles today and next time. But I have a little intro for you here for law of sines and how this works, okay? So to get started, what we're going to do, it says solve for h and the two triangles below. So on this triangle, we're going to use angle A. Okay, so we're going to use angle A. And then on this other triangle, we're going to use angle B. So would you agree h from angle A is the opposite? B is the hypotenuse. So the sine of angle A is going to equal h divided by b. And on this other triangle here, we have that the sine, or h is again the opposite, and a is the hypotenuse. So the sine of b would equal h divided by a. Well, here it says in the directions, solve for h. Okay, so how could I get h by itself? Well, I need to get rid of the divide by b. So we're going to multiply both sides by b. So h is going to equal b times the sine of a. And over here, I want to, again, have h by itself. So I need to get rid of this divide by a. And the opposite of that is multiply. So I have h equals a times the sine of b. Okay. And so on number 2 it says, using your two equations from question 1, write a new equation that expresses a relationship among A, B, angle A, angle B, side A, and side B. What's the relationship here of angle A, angle B, side A, and side B? Well, they're all equal to what? H. So if I have two expressions equal to h, would you agree that they equal each other? All right, so let's go ahead and write that. B times the sine of A will always equal the side length of A times the sine of B. So I really want you to think about where those parts are on the triangle. The little side length of B times the sine of angle A is always going to equal the side length of A times the sine of angle B. Okay, so number 3. Start with your equation for number 2 and divide both sides by AB. And what happens? So let's go back and write this again. So B times the sine of A, we said it was going to equal A times the sine of angle B. And I said to divide both sides by A and B. We can divide, if we're solving an equation, we can divide anything we want as long as we divide it on both sides of the equation. So if I was to reduce, kind of get rid of some, because all of these items are being multiplied together, I could cancel the b's on this side, and I could cancel the a's on this side. It's just the same as if I had like 10 over 50. What's that common factor that I could take out? So all we're doing here is taking out the common factors, the b's and the a's. So what's left? The sine of A over side little a is going to equal the sine of B divided by little b. Okay, and this is the basis for the law of sines and what is always true. And this applies, let's put these triangles together. So picture from the very top of the page, the triangle on the left and the triangle on the right being merged together. This was H, this was side B, and this was side A. Angle A, angle C, angle B. So on any non-right triangle, we can drop in the height or the altitude to create right triangles inside of there and use the straightforward trigonometry like we just did in number 2, and we solved for H, or in number 1 we solved for H. So these two triangles come inside of this one here. Okay? So any triangle that's non-right triangle can have an altitude dropped in, and we can use the ideas from law of sines. Okay, so we can solve for side A, B, or C, or angles, as long as we have the appropriate information. So go ahead and grab your purple packets. Keep that law of sines intro till next time. We'll use the back of it next time. And now let's go ahead and formally write up what is true on these non-right triangles, how we can solve for these sides. So, law of sines states that, first of all, I want to introduce you to possibly a new term, and that's oblique. An oblique triangle is a triangle that does not have a right angle. And if you want, I saw that angles was spelled wrong. You could fix that if you'd like. I don't know why spell check didn't point that out to me. So again, an oblique triangle is a triangle that does not consist of a right angle. And so we're going to use, to solve an oblique triangle, we have to know at least one side and any other two parts. Okay? So you have to have at least one side and any other two parts. So on a triangle, you have 6 pieces. You have 3 angles and 3 sides. Okay? As long as you have at least one side and any other 2 parts, you can use either law of sines or law of cosines. And so having those parts break into these scenarios. So you could have 2 angles and a side, similar to how we abbreviated our shortcuts. You could abbreviate them like this: angle, angle, side, angle, side, angle. And obviously in this case, we're only having one triangle. This is just the parts that you have on there. Option 2 is 2 sides and 1 angle not included. And what that means is not included means it's not the hinge point. It's not trapped. Okay? Option 3 is if you just have all 3 sides. And option 4 is if you have 2 sides and an included angle. So here the angle is trapped in between. And on case number 1, when you had 2 angles, the side could be trapped or not trapped. Okay? Trapped or not trapped. So this is case 1, 2, 3, and 4. The first 2 cases, case 1 and case 2, we'll look at today for law of sines. To be able to solve case 3 or case 4, we're going to have to use law of cosines, and we'll learn what that is next class. What questions do you have so far? All right. So, if you would flip the page, let's go ahead and define what we found earlier for the law of sines. Okay? So, we know that this is true. Law of sines. On any triangle ABC with sides A, B, and C, the side divided by the sine of the opposite angle is equal to side B divided by its opposite angle, which is also equal to C divided by sine of C. If I'm going to solve, I'm only going to use 2 of these fractions. I'm not going to use all 3, but it doesn't matter. I could put A with C, A with B, or I could put B and C together, okay? It doesn't matter which ones I use. This is a scenario, I just wanted to point out to you, we had those 2 triangles that were merged earlier where H was the altitude. So this is a non-right triangle where you can drop in that altitude. This is a situation where angle A is acute, where all 3 angles are acute. But if you have an obtuse angle, that height has to be explored on the exterior of the triangle, but the fractions that we explored in the intro still apply, okay? Now, some students prefer writing it like this, the side over the trig function, but it's true the other way as well, okay? So the reciprocal form, you could flip them, the sine of A over the angle, or the side, the sine of B over its side, the sine of C over its side. Okay, so what we're going to do now is we're going to apply this equation and solve. So if I'm trying to find a missing side, I'm going to use the traditional trigonometry when I'm solving. And if I'm trying to find a missing angle using this, I'd be using the trig inverse. So we really have to kind of merge everything from the last 2 class periods together. So let's look at example 1, and this is angle, angle, side. And the reason why it's written AAS is that this side B that I was given is not trapped in between. Okay? So what I need you to realize when you're looking at this is that you can use law of sines because you need 2 pieces that are opposite from each other. So angle B is given, and you have the opposite side B. As long as you have 2 pieces that are opposite from each other and any other third piece, you can use law of sines. But in your fraction, you have to have 2 vertical pieces that go together, and then you can solve. So, would you agree that I could write the sine of 28.7 divided by 27.4. They go together, and that's what we established in the equation, is that the sine of this angle divided by this side is the first part of my equation. Okay? Now, the directions here say solve the triangle. So I'm going to solve for side C because I have its angle. So I'm going to set this equal to the sine of angle C, which is 102.3, divided by side C. Now this is sometimes where students will start to kind of put parentheses maybe around the angles that they're working with, trying to keep everything organized, and so you know what you're trying to take the sine of and everything. So guys and gals, this mathematics right here, I'm trying to solve for side C. Okay, we can set cross products equal to each other. This is a fraction equal to a fraction. This takes us back to solving similar triangles. Okay, this is a proportion. So I'm going to set cross products equal to each other. So little side C times the sine of 28.7 is equal to 27.4 times the sine of 102.3. Sounds like a radio station. Okay? Now when I write my cross products times each other, I put these numbers out front. Okay? So C times 28.7 and equals 27.4 times sine of 102.3. Does everyone understand where I got that? that black line of text right there. I set cross products equal to each other. Now, I need to get C by itself. We haven't touched the calculator yet because we don't want to round any answers until we want to type this all in once we get the variable by itself. So if I want to get C by itself, would you agree we could divide by the sine of 28.7 on both sides? So it cancels over here, and now I'm ready to use my calculator. Now again, I really want you to write down what you type in your calculator so that if you get something wrong, I can see where you went wrong. So what we're going to type in our calculator is going to be 27.4 times the sine of 102.3, all divided by the sine of 28.7. Now I'm going to give you some suggestions here to get the right answer. You either need to start with an open parenthesis, type 27.4 times the sine of 102.3. Your calculator opens this parenthesis for you. You need to close this one and this one, and then you could type divided by the sine of 28.7. Or, guys and gals, you can type the numerator all together and hit enter, and then type in the denominator. But I'm going to go ahead and write up the answer right now so that you can type this in your calculator and see if you get it right. So this is a side, and I'm getting that side C is 55.7. Okay? 55.747. Is everyone able to get that? All right. So you can add that to the graphic up here if you'd like. Solve the triangle. What's the easy thing that we maybe could have done first if we wanted? Without using law of sines, what could we have added to this picture at the beginning? What? Angle A. Good. So in your calculators, would you please take 180 minus 102.3 minus 28.7? And you should be getting that the measure of angle A is 49 degrees. Now, you need that to find what? Why do we need that 49 degrees? We need to find this side A. We need at least one of the pieces from everything that's opposite from each other. Okay? Let's see here. Would you agree that the sine of 49 divided by little a could equal? Now this is where, guys and gals, I'm going to go back and I'm going to use sine of 28.7 in this 27.4 again, because heaven forbid if I get this wrong, this 55.7, then I'm for sure going to get this next part wrong. So just in case you don't get this right, I always try to go back. Now sometimes you're going to have to use pieces that you find to find other people. Like this 49, for instance. You had to find it, but I have to use it to get little a. And hopefully if we're just subtracting from 180, we wouldn't make a mistake right there. Okay? But the sine of 49 over little a is equal to, go ahead and write this down, sine of 28.7 divided by, again, that 27.4. Now, let's practice writing this out one more time. Cross products are equal to each other. A times the sine of 28.7 is going to equal 27.4 times now the sine of 49. And what I'm typing into my calculator, I think that we can probably not divide, I don't think we have to write this divide step out, but would you agree A is going to equal this 27.4 times the sine of 49 divided by, I need to divide this chunk over to the other side. Okay, that's what we're going to type into our calculator. 27.4 times the sine of 49 divided by the sine of 28.7. So one more time, if you want to type this all in at once, you need to put parentheses around the numerator. Otherwise, you can type in the numerator and hit enter and then divide by sine of 28.7. And I am getting 43.1. 43.1 for that last side. Okay. Let's try example 2. Example 2 is a little bit different. We have to solve the triangle here, and it's different because it's now angle, side, angle, where the side is trapped in between. Immediately here, guys and gals, we have to do what? To use law of sines. Yep, we have to find that third angle. So 180 minus 98 minus 43. Are we getting 39 degrees? Okay, so you have to find this third angle first. Okay, now I have two parts that are opposite from each other. So I can write that the sine of 22 divided by the sine of 39 equals, do we want to find B or A first? All right, so if I want to find B first, I'd write that that is equal to the sine of 98 divided by little b. Oh yes, goodness gracious, thank you. That would not have been good. The angle is 39 degrees and the side is 22. Please fix that if you need to. Sine of the angle divided by the side, sine of the angle divided by the side. So now we should be golden. We can say that b times the sine of 39 equals 22 times the sine of 98. Please make sure that you're getting this all wrote down, and for sure write down what you type in your calculator. The sine of, to get b by itself, I need to do what? I need to divide that sine of 39 to the other side. Okay, so 22 times the sine of 98 is going to be divided by the sine of 39. Did I hear 34.6? Good job. All right, so we're ready for little a. Again, I'm going to use my sine of 39 over 22, just in case I had a mistake on b. Sine of 39 over 22, and that could equal the sine of 43 divided by little a. So some of you are probably trying to see, like, what's the least amount of work I could write down, right? Maybe we could skip straight to what we type in the calculator. So you know that it's going to be this multiplied together, right? 22 times the sine of 43. And then you need to divide by the sine of 39. Now, I am in no way, shape, or form saying that you need to jump straight to this right here, but I want to make sure that you're making the correct jump if you're trying to do so. And then when you type that in your calculator, we should get 23.8. Does everyone agree? Hunter, is that what you got? Okay. All right, guys and gals, so now, okay, case 2. So remember how when we had 2 triangles and we were trying to prove them congruent and we had the bad word? It didn't prove congruence because we could have congruent triangles, but they also might not be congruent. The same thing happens here. When you have limited information, so that, again, you only have 3 pieces. You have one angle, one side, and another side. Because of the fact that the smallest 2 sides have to be bigger than the third, there is a chance that there might be no triangle that exists. Okay? There could be one triangle that exists if the first angle is acute that we're working with. But if an angle is obtuse in that triangle, there's 2 that could exist. Well, later on in Math 2 and Math 3, more likely in Math 3, you'll learn how to make those things determined. If I give you a problem to complete with its side angle, you will only have one triangle that's possible. Okay, but I just want to let you know that this is called the ambiguous case in law of sines because there's multiple opportunities for triangles here. Let's go ahead and try a couple of these. So this particular problem, there is only one possible solution, okay? Because I'm giving you the acute angle. If later on, if I don't give you that acute angle, then there's a chance that those are the types you're going to talk about in Math 3, like I just said. So first of all here, we can use law of sines because we have 2 pieces that are opposite from each other. Okay? What do we have to solve for first? I'm going to use angle A and its side, but what's the other piece they gave us? What side is this? That's side B. So we're going to use law of sines. Do you know what we're going to find first? And he said angle B. Yes. All right. So here we go. The sine of 42 divided by the opposite side, 22, is going to equal sine of B divided by its opposite side, 12. The first step of cross products is going to be the same. We're trying to get B. We want the answer for B. So we're still going to write cross products. We're going to say 12 times the sine of 42 equals 22 times the sine of B. Before I can get B by itself, I have to get rid of the 22. How do I get rid of 22? Divide. So I divide the 22 over, so it's gone. So I have sine of B right now is equal to 12 times the sine of 42 divided by 22. Now, how do I get B by itself? Any suggestions? I can't divide by sine. What's inverse? I need the sine inverse. I need to get sine to the other side, and to do that, it's the inverse. So B is going to equal the sine inverse of everything over here. going to be angle B is going to equal the sine inverse of 12 times the sine of 42 divided by 22. Now remember earlier when we were solving, I said, hey, you can put parentheses around the numerator, or you can type in the numerator, hit enter, and divide. Well, you're going to have to use a lot of parentheses on this, guys and gals. Okay, get your calculators ready. Everyone right now, you're going to type sine inverse. Everyone ready? Type sine inverse. I need you to open up this big parenthesis. And then I need you to type a second parenthesis. Okay, I'm going to change colors for that one. That one's going to be in green. Then you're going to type 12 times the sine of 42. Now when you type sine, remember it puts out parentheses for you. So you're going to have one parenthesis around 42. So then you close it. Then you need to close the green one. So we open, close, close. Then so after the 42, you need two parentheses, closing. Then, guys and gals, you hit divide by 22. You have to do this all in one step. You can't hit enter and then divide by 22. You have to do that all in one step. Your answer is 21. Yes? Now you're getting 21 point something, but we're going to round to the nearest whole degree. 21 degrees. Okay? So we can add that to our picture. Second step, what do you think we should do? Angle C. Good. So angle C is what? 180 minus 42 minus 21? 117 degrees. Measure of angle C, 117. Now, the last thing is to find side C. Okay? Find side C. So you could do the sine of 117 divided by C equals. Now again, we found this 21. I'm going to go back and I'm going to use my sine of 42 over 22. Use those numbers that were given to you. And this is again finding the side length. You set cross products equal to each other. C times the sine of 42 must equal 22 times the sine of 117. We can divide both sides by the sine of 42, so bring that over. What I'm typing in my calculator is 22 times the sine of 117 divided by sine of 42. Tanner, what'd you get? Does everyone agree with that? Side C, 29.3? Yes? All right. Well, guys and gals, that concludes the law of sines